Alright, welcome to our lesson today on mixed and entire radicals. So today we will learn how to convert radicals into mixed radicals or into its simplest form, and the other way around too, where we convert the mixed radicals back into its original form or the entire radicals. Alright, so before we begin, this is a very important property to remember, the multiplication property of radicals. So whenever we have a number under the same root, we can actually split it into its factors under the same root as well. Right? So for example, let's take the square root of 144. Right? So the square root of 144, or 144 by itself, right? We can write 144 as 9 times 16. Right? So what we can do now is the square root of 144 will then equal to square root of 9 times the square root of 16. Right? So again, this is because of the multiplication property of the radicals. And from that, we can just say, oh, square root of 9 is 3, square root of 16 is 4, which means that 144 square rooted is just 12. Right? So now this works for any other root as well, right? So let's take the cube root, for example. 216, we can write that as 8 times 27. Right? So the cube root of 216 is just the cube root of 8 times the cube root of 27. Right? And this will get us 2 times 3, or 6. Right? So the cube root of 216 is 6. So now this is what it means to have the multiplication property. We can take a number by itself in a root and split it up into its factors. Right? So now, something interesting here. The 144 and 216, those are perfect squares and a perfect cube. However, we get something like square root of 24. Right? This is very common. And this is not a perfect square, so we cannot just like square root it. 25 is a perfect square, but not 24. But what we can do is simplify it. So with the square root of 24, we can write that as 4 times 6. Right? So, I guess the dot and the cross doesn't really matter. Right? So we can write 24 as the square root of 4 and the square root of 6. And we know that the square root of 4 is 2. And the square root of 6 is not a perfect square, so we can just leave it as it is. Okay, so what we're doing here is simplifying the square root of 24. So all we did now is to make the square root of 24 just a little bit easier for us to work with. We just have smaller numbers to work with. This is pretty much, you can think of it as simplifying fractions. Right? The reason we simplify fractions is so instead of having something like 15 over, let's say 20, right? Instead of a big fraction like this, we can reduce it down to, no, not 5, that'll be 3 over 4. Right, we can reduce it down to 3 over 4, right? So 3 over 4 is a much smaller numbers to work with than 15 over 20. Right? So what we did here is, with 24, we found a number, we found a factor we can take out that is also a perfect square. Right? So with 24, we could have easily done, say, square root of 3 times the square root of 8, or square root of 12 times square root of 2, all that kind of stuff, right? But we took out the square root of 4 and the square root of 6 because 4 is a perfect square, which means that we can square root 4 without any decimals, right? It's a nice clean number to square root. So what we end up having here is the square root of 4 times the square root of 6, and because you know the square root of 4 is 2, again, no decimals, clean number, we get 2 times the square root of 6. Right? The square root of 6 will be a big decimal. What would that be, like 2.5 something like that, right? It's going to be a huge decimal, so we'll just leave it as the square root of 6 by itself. So with that being said, let's try some examples. So something that will probably make our life easier is to just list out a bunch of perfect squares that we can use. Right? So a perfect square would be things like 1, a 4, which is 2 squared, we have a 9, which is 3 squared, a 16, that's 4 squared, 5 squared, 6 squared, 7 squared, so on and so forth, right? So those are perfect squares. This is ideally what we are taking out of each question. So now take the first example here. Just square root of 80 here. Right? So with the square root of 80, we know that 80, we can split that into the factors of 4 times 20. Okay? So we have 4 times the 20, which gets us 2 times the square root of 20. Right? So right away, it's already looking a lot smaller. So all we did here is taking out a perfect square as one of the factors. Right? So now we notice that 20, it can actually be simplified even further. Right? 20 is just 4 times 5. brackets, we have 4 times 5, which means that the square root of 20 can be expressed as 2 times 2 root 5, which equals to 4 root 5. Right? So yeah, that's how we simplify the square root of 80 here. So all we are doing is taking out factors of 80 that are perfect squares. So again, very similar to reducing fractions. Right? And we can also notice here that we could have just taken out a 16 instead, right? With the square root of 18, we can write up here. Oh, not 18, sorry, 80. With the square root of 80 here, this could have been square root of 16 times the square root of 5. Right? This is the same thing. And we know the square root of 16 is 4. And we just have square root of 5, which is not a perfect square. And we'll get the same answer. Right? So again, it's just nicer to work with. Instead of working with the square root of 80, we're working with 4 times the square root of 5. So way smaller numbers. Right? We'll actually skip the middle one and go to the next one here. Right? The square root of 200. So with the same logic, we can take out whatever we want. Right? We can take out a 4, because we know 200 is divisible by 4. Right? But we can also take out a 100. Because we know 200 is just 100 times 2. So we can just take out the square root of 100 and the square root of 2. The square root of 100 is just 10. We just have the square root of 2. And that's all it is. Right? So again, we could have taken out 40 if we want to, right? 40 times 5. We could have taken out, what else can we do? 20. We can do 20 times 10, right? So we could have done all those factors. But at the end of the day, we could only take out factors that are perfect squares. Okay? So with the same logic, the cube root of 144, we can also take out cubes, right? Because this is asking us to simplify a cube root, we're taking out perfect cubes instead. So instead of the 1, 4, 9, 16, all that, we'll take out cube roots. So we got 1, we got 8, which is 2 cubed. We got 27, which is 3 cubed. And we have 64, that's 4 cubed, so on and so forth. So it was 144. Let's see, what is it divisible by? It's probably divisible by 8, right? Yeah, it is divisible by 8, right? So with the cube root of 144, right, the cube root of 144, we can write that as the cube root of 8 times the cube root of, let's see, 144 divided by 8. What is this? 1, 64, 18. Okay. That looks so off. 1 times 18. Yeah, that's right. Okay. All right. So here's what we have. We know the cube root of 8 is just 2. And then we will times that by the cube root of 18. Right? So with the cube root of 18, that cannot be simplified further because 18 cannot be cube rooted. So we leave it as it is. Once again, all we're doing here, taking out a factor, so in this case a 4 and 100, that are perfect squares, or in the case of the cube roots, an 8, which is a perfect cube. Right? So this is how I simplify them. Okay, now the other way around, which is a lot easier in my opinion. Right? So if we want to convert, actually before we go on, this right here is called a mixed radical form. So this is where we have a big number in front of the radical. Right, so as we can see, this is very similar to the mixed fractions and the regular fractions, or the improper fractions. Right, so we're essentially using the same idea. So now with that being said, let's check out converting the other way around. So from mixed radicals to the entire radical. So this is, I think it's a little bit easier. Right, so we have the first question here, 4 times the square root of 3. So we know that because it's a square root, we know that the 4 would have been squared in the first place to get to that point. Which means that in order to convert it back, we just square the 4, right? We just square the number in front of it. So in this case, this would just equals to the square root of 4 square rooted times the square root of 3, right? Which is the square root of 16 times the square root of 3, which is the square root of 48, right? Just like that. And similarly, with the next one, 3 times the cube root of 2. Once again, we can just cube the first number and then multiply it by 2, all under a cube root. So this equals to the cube root of 3 cubed times the cube root of 2, which is the cube root of 27 times the cube root of 2, getting us the cube root of 54. All right, and lastly, we have the fifth root here, which with the same logic, it would just be 2 to the power of 5. Right? So in this, we can just actually write it all in the same fifth root. So 2 to the power 5 times 2 here. So that's pretty much 2 to the power 6, which is, what is that? 2, 4, 8, 16, 30, 64. Right, just like that. So, yeah, I think going the other way around is a lot easier, right? So this is us going from a mixed fraction to improper fraction. Again, not the same procedure, but this is like the idea of why we're doing this. So there we go. With that being said, let's do some practice questions. So pause the video here and try to do those yourself, and we'll go over the answers in a bit. Okay, so I hope you had some time to pause the video and do them yourself. Right, so let's see, the square root of 90. So we can split the 90 into 9 times 10. Right, once again, the reason why we do 9 in particular, out of all the factors we could have taken, is because 9 is a perfect square. Right, so with 9 times 10, we have 3 times the square root of 10. Right, and that's that. Okay, 54. So once again, we can also take out a 9 as well. So 54 is just the square root of 9 times the square root of 6, which gets us 3 times the square root of 6. Alright, very good. Okay, so now let's do some bigger numbers here, cube roots. So in this question, 128. So with all the cube roots, we can find that 128 is divisible by 8. Right? So again, we're picking 8 here because it is a perfect cube. Right? So which means that we can cube root 8 without any decimals. So 128 is just 8 times 16. Right? So be very careful here. The 16 in this case is not a perfect cube. We can square root 16 to get 4. But when we cube root 16, there isn't a number that multiplies 3 times gets us 16. Right? So we have to leave it as it is. So the cube root of 8 is 2, leaving us 2 times the cube root of 16. And now lastly, with 250 here, we can take out 125. Because 125 is a perfect cubed. We'll let with a 2 left over. Right? So the cube root of 125 is 5 times the cube root of 2, getting us the cube root of 250. Right? So yeah, that's pretty much it for the mixed radicals. So now let's go the other way back, the other way around. So 3 times the square root of 2. Okay? All we have is we can square 3 here and then multiply it by 2 by itself, getting us 9 times 2, which is the square root of 18. Then next, same logic applies. We got the cube root now. So instead of squaring the 5, we cube the 5. Right? And very conveniently, we actually get back 250. Okay, and lastly, the 2 times the cube root of 9. Right? So we will cube the 2, slap it into the root, getting us 8 times 9, which is 72. Alright, and yeah, that's pretty much it. So in all those exercises, all we are doing here is to make the number a bit smaller to work with. And when we do that by taking out factors that are perfect squares or perfect cubes or perfect whatever, depending on the cube number. So once again, take 8 here for example. We're taking out a 4 to get 4 times 20 because 4 is a perfect square. Right? We could have easily taken out an 8 for example. We would have gotten the square root of 80 equals to the square root of 8 times the square root of 10. But square root of 8, we can't really square root that. Square root of 10, can't really square root that. Right? So we're taking out perfect squares just so we can get whole numbers at the front. Right? So that's pretty much it. So keep practicing and stay hydrated.